Hello everybody, Steve Matthews here. Today is February 27th of 2019, and you can find me on YouTube under Teeth of the Lamb, all one word, and also on Facebook under Steve Matthews. So I'd like to talk about how your angle of view and your perspective would actually work if we were actually living on a sphere. I'm going to show you some simple diagrams, some very simple motions, and talk about what they call field rotation, which is nothing more than the stars as they move across the sky and rotate, and the moon as well. They say the stars are fixed in the sky, that they're too far away, and it's the motion of the Earth that causes this appearance of rotation. The moon moves, but rather slowly, about 15 degrees across the sky per hour, but also the face of the moon rotates, and there's no account for these motions that we see in the sky on a sphere, and I'm going to demonstrate why that is. I'm going to show you a popular demonstration that the ballers use to show why we see the moon and the stars rotate as they traverse across the sky. Well, it's airplanes that they use flying overhead, and if you've ever filmed anything overhead, you have to turn when it passes over your head. And I'm going to show you that it's nothing more than camera rotation that they're showing you, and it's not explaining why the moon and the constellations appear to have a rotation as they go across the sky. It doesn't explain it at all. In my demonstration, I'm going to use two photographs that I took of the moon, one in the east as it was rising and one in the west as it was setting. We'll take into account that from a fixed position on the Earth that we see these rotations, and location doesn't change the outcome. Perspective doesn't change the outcome. We only have one perspective of the moon. And parallax doesn't change anything either as we view the moon. The moon is simply too far away using the heliocentric numbers. And what I mean by heliocentric, all that means is sun-centered. Everything revolves around the sun. And it's what you've been taught in school. First, we're going to look at a short clip from a video where they're claiming that it's the camera and the arch of the moon moving over the sky that causes the rotation to appear when you take pictures of the moon every hour or so throughout the day or night. But I say the camera is showing us exactly what's reality, and I'm going to show that to you today. Then next we're going to look at a short clip of the jets flying overhead, and we're going to look at that more closely. And we'll talk about those two things and see which one is right. I'll present it, and you decide. The claim that planes flying overhead demonstrate field rotation is utterly and absolutely false. What that demonstrates is that the camera must be rotated, nothing more. The frequent random variations in the movement of the face of the moon as it rotates across the sky is not possible in the heliocentric model. We see the moon's rotation sometimes fast, sometimes slow, and other times not at all. So now we'll play the clips that we're going to be talking about today.
So I'm going to run this forward again, and this time we can see more clearly because I'm zoomed up and the daylight is off. We're going to look at the angle of the moon, the apparent angle to the observer. So as I run this forward, we can see that apparent angle is tilting over, and that terminator line is coming up to perpendicular from our point of view. It's rotating clockwise, and now it is tipping over and I believe that this is what Catfish is talking about. But this is simply caused by field rotation, as has been explained previously. Let's have a look at this video of this Concorde aircraft flying across the sky from east to west, as if we are looking north. This is the sort of view that we would have from the southern hemisphere if we were comparing it to the moon. We can see now that the angle that the aircraft are pointing in our photographs are quite different in each photo. We can see now that the angle that the aircraft are pointing in our photographs are quite different in each photo.
Okay, so he doesn't film what he did. He rotated his body and his camera to get those shots. So let's take a look at some more footage of some airplanes flying overhead, and then we're going to talk about this. So here we go. Picture number 1 is taken at that angle. Picture number 2 at that angle, and picture number 3. He demonstrated what comes natural to rotate your body as you would have to film something flying over your head. And here are the 3 different angles. So let's look at a little bit more of people actually doing that. A few other clips here. So what I see is that a person has to rotate their body and their camera when they're filming something flying overhead that's close by. The moon isn't that close. They say it's on average 239,000 miles away from the Earth. Now, that changes everything. They love to ignore the distances when it's convenient, and then they use the distances when it is convenient. But we have to take that into account. It's real simple here. The only motion we're really dealing with is the motion of the Earth. The sun is fixed, and the moon might as well be fixed because it's only moving 15 degrees in our sky per hour. So let's look at that a little bit more closely. Here are 2 photographs that I took of the moon. One was at 6:22 p.m. in the east, and the other was at 6:47 a.m. in the west as it was setting. Now, all I did to get these 2 pictures was simply panned my camera across the horizon from the east, panned it clear around to the west. And these 2 images should appear the same if we aren't seeing the moon actually rotating. You can see the Sea of Crises on the top, the round sea on the top, on the left-hand side. Well, it's moved a quarter of a turn in nearly 12 hours. So what does that mean? That means that from 6:30 at night to 6:47 in the morning, something has happened to that moon, and it's moved, rotated. And it's not an illusion, it's a reality. The moon has moved, apparently moved, in our sky 180 degrees. That's 15 degrees per hour times 12. And the actual movement of the moon has been about 12 degrees counterclockwise around the Earth. So it didn't move much itself. So what we're dealing with here is just the rotation of the Earth. The sun is fixed. The moon only moved 12 degrees physically. So just the rotation of the Earth. So what caused that rotation? It's not an illusion, like I said. And we're going to look at that here. The only movement in my camera was horizontal, as I had it pointed toward the east, and I rotate around to the west as the moon was setting. And that's it. To help better understand, I've made a diagram here. The pie chart is basically the orbit of the moon, and you'll see at the end of the blue dots on the outer edge of the pie chart on the top is a little red dot that represents the moon. And in the center of the pie chart is a blue dot, the bottom blue dot, that would represent the Earth. And there are 30 blue dots going out to the moon. That's the distance they say the moon is away from the Earth. Now the pie chart is the orbit of the moon, and it's broken up into 5-hour slices. So each slice is 5 hours. Now visualize this. If you were standing on the center blue dot and you were looking at that moon, what would you see? You can't change your perspective. The Earth isn't big enough. Even if you stood on the outer edges of the orbit of the moon, would still not be far enough to change your perspective. So the only motion we're dealing with is just a little over 2 slices of the pie moving left. That's all the moon moved, and the Earth has spun half a turn. That's the difference between the first photo I took and the last photo I took. So let's look at that even more closely. I'm going to blow up the image of the bottom circle so we can see what's happening. So this will be easier to see. The lime green dot in the center is the Earth. That's where we're standing. And the red dot at the end of the blue dots is the moon. That's how far away it is. You can't move on that Earth from one side to the other far enough to change your perspective whatsoever. And the larger Earth at the bottom is in sun, the sun's hitting one side and the dark side, and the only thing that's going to happen is the Earth is going to rotate to the left, which is counterclockwise. Remember, the moon is only going to move about 2 slices of the pie to the left as well. So these are the 2 motions we have to deal with. And how do we get those two, the rotation of the face of the moon, out of this? That's the conundrum. That's the question. Okay, so let's look at this more closely. I'm going to put a red dot on this Earth on the bottom, on the dark side, and I'm going to rotate it around to the other side, and that would be representing my perspective of the moon during that 12-hour period between the photographs. So we're going to look at this a little differently here. We're just going to deal with the rotation of the Earth. The red dot is going to move from one side to the other side of the dark as it rotates counterclockwise. And we're going to forget about the moon. It's moving 2 slices, which is about 12 degrees counterclockwise. So I think that's irrelevant. We've only got one motion to worry about, the rotation of the Earth. In the video window, I'll rotate my camera to show you the motion it made from one photograph of the moon at night to the other photograph in the morning when it was setting. So let's take a look at this here, as that red dot's going to move on the Earth from one side to the other. So my camera is rotating to the west, and there we go. That's all that was taking place. Remember, the sun is stationary, and so there's always a dark side of the Earth, and the Earth is the only thing that spins. The dark side doesn't move. And the moon had only moved 2 slices of the pie. So where in the world did this rotation of the face of the moon come into play? It didn't. So it's real. It is what we see. And you can see my angle, even on the larger Earth, still isn't sufficient to make any perspective change whatsoever. But on the lime dot, absolutely no way we got a different perspective. Now here's a view from the west. So very little has changed. Remember, I'm standing on that lime dot 30 Earths away from the moon, which is 239,000 miles. You can't get any perspective change because perspective requires motion. You have to move a significant amount to change your perspective. This phony term, field rotation, yes, the moon and the stars do rotate. They rotate in the firmament right above our heads. And they have no explanation for it, so they try to twist everything all up. You can't get field rotation out of the movement that I just showed you. The only thing of significance was that the Earth spun, and that's it. I want to drive the point home at how far away that moon is. See, the lime dot on the left is the Earth, and the moon is the little red dot on the right. There are 30 Earths between us, and if you were standing on one side of that lime dot or the other, follow the red line, you can't get a different perspective. And you definitely aren't going to get rotation out of perspective. There's no way. So I say the moon is spinning, and I defy anybody to show me a diagram that'll prove it any different. It's real simple. The only thing that moves significantly is the spin of the Earth. And it doesn't matter where you stand on that Earth. Your perspective of that red dot isn't going to change whatsoever. Here's the image I took in the morning in my east, and the center white deal is a camera. And I took one photo. Then in the west, I took one photo. Only thing was a pan, horizontal pan of the camera. Here's another little test. I got on the merry-go-round to demonstrate, let's say the merry-go-round is the Earth. To demonstrate, I've got 2 white boards way off across the field there, and I'm going to film them. This is what happens. Okay, here's the merry-go-round, give you a view of where I'm at. See those white boards way out there? I put 2 of them up so you can see that I'm actually moving. And the only thing that happens here is the black dot on the top doesn't move, and I'm having a hard time holding my camera steady. But the one on the right, see how it's moving closer? That's the only thing that happened as I stood on that merry-go-round and spun it half a turn. The only thing that happened was the back one moved behind the other. Here we go again. I'll do it one more time. And really hard holding it on a zoom on that merry-go-round. I'm going all over the place, but you can see what's happening. Nothing. There's no rotation whatsoever, and it's the same, duplicating the same motion that happened during the photos I took. So here's some more demonstration. The distant mountains don't move. It's the stuff in between that moves. So the moon at 239,000 miles is standing still. I mean, these mountains aren't that far away. So they don't move, but all the stuff in front, which is called parallax, that's what they have the shooters and stuff have to put their crosshairs at the same plane as the distant object so they don't get that parallax and that movement. Close objects will show a lot of movement. Distant objects won't show any at all. And the moon absolutely would show no detectable movement whatsoever. You can see those distant objects stay still. And if the moon was up in the sky, a lot of kids, when you're driving down the road, they'll say, hey, the moon's following us. Well, that's because it doesn't seem to move, no matter how far you go on the Earth. Only when the Earth spins, of course I don't believe in that garbage, then you've got Polaris. It doesn't move. It never has. And so you've got another problem. We've got our sun, moon, and stars that move above a stationary Earth, and there's no other way around it. These stars are rotating, and if you were to plot the constellations, they give a spin too, just like the face of the moon. And that's not anything except reality, and you can't explain it away. So please like and subscribe, and everybody have a darn nice day.
Why did you